Hello, everyone. We are doing the final review of our class. So first problem we're going to look at is this operational amplifier. So it is asks you to draw the input voltage and output voltage. So let's look at the input voltage first. So the input voltage is 1 sine 200 pi t. And we know the value inside the sine function is, we call it angular frequency. Angular frequency. So angular frequency omega equals 2 pi f. So f is the frequency. So 200 pi, so omega equals, I write it here. So omega equals 2 pi f. So we have 200 pi equals 2 pi f. So f equals 100 hertz. And for the time period is 1 over f, which is 1 over 100 is 0.01 seconds. So it is a sine function, its amplitude is 1. So we know from 0 to 0.01, there's a sine function. And its amplitude is 1. So this is peak. The peak is 1. So this is peak, it is 1. It is -1. And because it's a sine, so we have another sine function here. And this is 0.02 seconds. And then this is another sine. And so this is the input voltage. And then we look at this amplifier. So in this amplifier, because the feedback, it has a negative feedback. So you have a negative feedback and connects to the this negative terminal, because for OP, for an operation amplifier, we always use negative feedback. And also the input voltage connects to the negative terminal. It means it's an inverting amplifier. And so we can immediately know that since it's inverting amplifier, its gain, its voltage gain is minus RF over RI, which is minus 100 over 50, which is -2. Okay, so VOT equals AV VIT, which is -2 times 1 sine 200 pi t is -2. is -2. I write it here. -2 sine 200 pi t. So it has the same frequency, but right now the amplitude becomes negative. It means it has out of phase. Out of phase. So since this is out of phase, so we have this. So out of phase. Still, this is they have the same frequency, which means they have the same period. But right now it becomes out of phase. So 1 becomes 2. So this is -2. This is 2. So at out of phase. Out of phase. This is 0.02 seconds out of phase. So which is the answer? 好，这一题首先就是这一题是你要注意的，这个放大器是非反向放大器。为什么它是非反向呢？因为你的输入电压连接到放大器的负极，那我们称作这是非反向放大器 （inverting）。我们称作这是反向放大器 （inverting amplifier）。所以呢，那一旦知道它是反向放大器，那我们就是可以把它的电压增益写出来。那电压增益是负的 Rf 除以 Ri， 这个是 Rf feedback 的 resistor， 就是100欧姆，这是 Rf。然后这是 Ri， 这是 input resistor， 那得到它的电压增益是-2，所以我们输出电压跟输入电压有这个关系。那它的答案是-2 sin 200 pi t， 电压的频率不变，那此时它的增益从正一变-2，那我们知道它就是我们称作它是反向 out of phase， 所以原本呢在1的时候会有一个峰值，此时变得是在-2的地方呢会有一个低谷，那就是它的高峰跟低谷刚好是相反的，然后它们频率不变，所以它们有同样的周期。好，这就是第一题的解答。OK， let's look at the second problem. Okay, for the following amplifier, and it tells you all these values. It told you the value of V1, V2, R1, R2, R3, and R4. Please calculate the output voltage. Okay, so assume this is we assume this point what happened? Please okay, so we assume this is A, this point is A, we assume this is point is B. So for an amplifier, for this it is enclosed, this is closed loop amplifier. It needs to satisfy golden rule. The golden rule tells us VA equals VB because it's a closed loop. And golden rule also tells us there's no current. This is IA. This is IB. We're going to turn IA equals 0. IB equals 0. Okay, so 第一件事就是，如果这个运算放大器它是闭回路的时候，那就要满足这个黄金法则，就是 A 的电压等于 B 的电压，而且流入放大器的电流 IA 还有 IB 为零。Okay, this is golden rule. And once we know golden rule, we need to apply KCL at each node. For example, we can have KCL at node A. And we can assume this is I1, this is I2. The direction of current doesn't matter. Okay, because we just assume it. So because I1 equals I2, so we have, this is V1 minus VA divided by R1 equals what? VA minus VO divided by R4. Okay, so since we know the value of V1 is 30 minus VA is unknown. And divided by R1 is 5 equals VA minus VO divided by R4. R4 is 35. So we got our first equation. Okay. And second equation, the same we apply KCL at node B. So another equation is KCL at node B. And the same thing, we can assume this is I3. And then we assume this is I4. So KCL at node B, we have I3 equals I4. And then we have I3 is the same thing, the direction doesn't matter. So yeah, the direction of I3 and I4 doesn't matter. So we have V2 minus VB and divided by R2 and equals VB minus 0 divided by R3. And then we put values into this equation. It will become, this is V2 is what? V2 is 20 minus VB. And we have divided by R2. The value of R2 is 5 equals VB minus 0 divided by R3. So R3 is 35. Okay, R3 is also 35. And so this is our first equation. This is the second equation. And we have 3 unknowns, right? The unknown is VA. And the second unknown is VO. And we also have the third unknown is VB. But according to a golden rule, we have VA equals VB. So this is our third equation. So from this one, you have 3 variables and 3 equations. You are able to solve a system of equation. So in the end, VO equals minus 70 volts. And you can also solve VA and VB. And I'll let you calculate on your own. 好，这一题，这一题的话呢，就是你要利用这个 Golden Rule，那你使用KCL 在 A 点跟 B 点呢，用 KCL 来计算，来列出方程式。那所以在 A 点的 KCL 它是 I1 等于 I2，因为 IA 等于0，所以得到 I1 与 I2，然后利用欧姆定律可以得到第一个式子。同理，在 B 点，那你的 KCL 在 B 点的 KCL 呢是 I3 等于 I4，因为 IB 为0，那得到第二条方程式。那此时呢 ，VA、VB 是跟 VO 是未知，有3个未知数，所以要加入第3条方程式。第3条方程式呢，就是由我们的 Golden Rule 来得到是 VA 等于 VB。那你解这个3个方程式的联立之后，会得到 VO 等于负70伏特。你也可以把 VA 还有 VB 求出来，它们会相等。Okay, so this is the end solution to the second problem. Okay, so let's look at the third problem. Okay, the third problem is this. So it asks you to calculate the real power of this circuit, the reactive power of this circuit, the power factor, and the force is the parallel capacitance required to correct the power factor to near 0.9 lag, and you have to write the correct unit to get a full score. So, first of all, we need to write, so if for calculate real power, reactive power, and power factor, we need to calculate the phasor of the source and the current of this source, right? The phasor current of the source. So we need to calculate V and I. So suppose V, we have V, this is angle theta V. And then we calculate the phasor current is I, angle theta I. And so the real power, and we define theta Z equals theta V minus theta I. So the real power use a capital S, right? Real power is, what is it, S? No, the real power is P. Apparent power is, let me double check. P, Q, and S, right? So let me see if I'm correct. So we have apparent power. Yeah, apparent power is S. So apparent power, you have this. You need to think of power triangle. This is S, this is P, this is Q. So P is the real power, Q is reactive power, and S is apparent. A-P-P-A-R-E-N-T. This is apparent power. Okay, so A-P-P-A-R-E-N-T. And so this is theta z. So you have this relationship. And remember the unit. The unit of apparent power is voltage amp, VA. This is the unit. And the unit of real power is watts or k-watts. Okay. And the unit for reactive power, we use VAR. Okay, so the unit, you need to write the correct unit to get a full score. So for the problem A, we need to calculate the real power. So we know real power equals VRMS times IRMS, right? Or it can be written as 1/2 VI. Okay, but it's easier to memorize this way. Okay, and so we need to find out the phasor of voltage and phasor of current first. So the phasor of voltage here, because it is cosine, it has 0-degree phase angle. So V equals, so we know V equals 200, its amplitude, and 0-degree. Okay, and then we need to calculate I. But before we calculate I, we need to calculate the phasor, the impedance of this. So the impedance of the load is 50 plus, it tells you it is J50. So the phasor I, the phasor current is, we just apply Ohm's law for the impedance. The phasor voltage divided by impedance is 200, 0-degree, 50 plus J50. And so the division of the complex number, we must convert everything to polar form. So what's on the numerator is polar form ready, and for the what is on the denominator, the polar form is 50 times square root of 2, and this is 45-degree. Okay, so you can have these 2.828 degree minus 45-degree. Okay, so we have this. This is V, this is I. So we can start solving problem A. Problem A, the real power, we need to solve apparent power first. So we have S equals 1/2, but because I already have V and I here, so I just 1/2, this is V is 200. Yeah, you can also memorize this. 200 times 2.828, it is 282.8. This is voltage amp. This is the apparent power. And so the real power P is from the power triangle. P is S times cosine theta z. And the theta z is, wait, this is 45. This is minus 45. Okay. This is 45. This is theta z. Theta z is vi minus vb minus vi. Okay, theta z is vb minus vi. Okay, yes, okay. So theta z. So because theta z is theta v minus theta I, so this is theta v is 0 here. Theta I is minus 45. So theta z is 45 degree. Okay, so P is S is 2A 2.A cosine 45 degree times cosine 45 degree. So which is 200. Unit is watt. Okay, so this is the answer. Real power is 200 watt. Okay, let me explain Chinese before we move on. 好，第一题就是要求你的实功率 real power。那我们这边已经稍微复习了一下，我们所谓的功率三角形。那这个电路的功率三角形，首先你要把电压的这个向量，还有电流的向量求出来。然后向量包含了它们的大小值，还有它们的相位角。然后西塔 z 呢就会是西塔 v 减西塔 i。那它们的功率三角形就有这样的关系，有实在功率 apparent power 实功率跟这个虚功率 reactive power， 然后它们的单位是不一样的。实在功率它的单位是 VA， 虚功率它的单位是 VAR， 你可以记作它是 reactive， 所以它是 voltage amp reactive。那实功率就是瓦特或是用千瓦。好，那我们的实在功率的公式可以记成这样，你可以记成 VRMS 乘上 IRMS， 或是1/2的 VI。V 跟 I 分别为这个电压向量跟电流向量的正负值，或者是我们说是大小值。OK， 好，那我们一开始呢，就是先求这个电压的向量，还有电流的向量。那电流的向量呢，我们要把它的这个总阻抗算出来。那它的总阻抗，它已经告诉你是50欧姆加上 J50欧姆。J50欧姆它是一个正的虚数，所以我们知道它是一个电感。那所以我们得到我们的负载的总阻抗，所以我们可以套用呢这个欧姆定律 I 等于 V 除以 Z， 那来计算它的电流的向量为何。那我们就是计算出来电流的向量是这个，它有一个大小值，还有一个相位角。那我们就可以开始来算我们的各个这个实在功率、实功率跟虚功率了。那我们就是用套入刚刚的那个公式呢，算出我们的这个是 P 是实功率 real power。Okay, and then we move on. We look at B. Reactive power is Q. So Q equals S times sine theta Z, which is 282 point A times sine 45 degree, which is the same, which is 200, but right now the unit is VAR. So you have to write the answer. This is 200 VAR. Okay, and the power factor in short is PF equals cosine theta z is cosine 45 degree, which is what? 0.708, 707, 0.707. Okay, this is the ABC, and look at D. The parallel capacitance required to correct the power factor to 0.9 lag. So let me use a different color for this one. I use color black. So we need to connect to a capacitor. Suppose this is C, and ZC equals J. This is 1 over J omega C, right? And unit is ohm. The resistance, the impedance, the unit for impedance is ohm. And because they have the same voltage, so we can write the equation by using complex power. So the complex power S equals 1 over 2 B squared divided by R plus J 1 over 2 B squared divided by X. So we have this complex power equation when two components are in parallel, and then to reduce power factor to 0.9, we need to calculate the new theta z. So this should be cosine theta z prime. This is our new theta z. So our new theta z prime can be arc cosine 0.9, which is 25.842 degree. So we know that we need to reduce power factor, so this will be our new theta z prime. This is our new Q. This is Q prime. So we want to reduce our reactive power from Q to Q prime. So this is what we want to reduce. Okay, so the Q prime. So what is Q prime? And let me see if we have, okay, we only have this page. So I write it here. So Q prime will be 200 times sine. This is 25 point 8, 4, 2, 3, which is the Q prime is no, it should be tangent, right? Tangent, and which is 96.865, and its reactive power is VAR. Okay, so it reduced from the reactive power must reduce from 200 to 96, and the reduction is fully contributed by this. Okay, so the reduction, so that JC, let me write it here. Theta Z, this ZC equals J omega C, this is 1. So this is 1 over J. Omega is 120 pi. This is C, we don't know C. So we revise this a little bit, is -1. We times J on the numerator and denominator. So, and this is 120 pi C, this is J. Okay, so this is our X equals XJ. This is our X. Okay, so the reduction of Q, the reduction of the reactive power is contributed by this the impedance of capacitance in parallel. So we have this relationship. We have the reduction delta Q is no, let me do not write delta Q. Let me say Q minus Q prime. The reduction of the reactive power is contributed by this 1 over 2 V squared divided by X. This is minus, right? Because okay, this is the remainder. This is X. So we have Q is 200 minus Q prime. Let me Q prime minus Q. Okay. We say, how about we say the reduction? Let me say Q prime minus Q. So we have minus 200 equals 1 over 2 V squared, and V is 200. And this is X. This is -1. C. This is our X. Okay. And so C will be, so we'll solve C by using this equation. You solve C, and C will be 13.679 mu F. So this is 13.679 mu F. Okay, let's explain in Chinese. 好，那第一小题呢，他说要加一个并联的电容，那将这个功率因子呢校正到0.9，因为我们希望功率因子越大越好，因为功率因子越大呢，它的市载功率就可以减少。你可以用比较小的市载功率提供同样的时功率。那我们首先你就必须算，你把这个功率因子增加到0.9的时候，此时它的这个所谓的角度西塔 z prime 新的西塔 z prime 要变成多少？所以呢，我们就是用这个 inverse cosine 去算新的西塔 z prime 要变成25.842度，所以它从原先的45度变成25.842度。那此时呢，新的虚功率是多少？新的虚功率呢 ，Q prime 它就是变小了，它只有96.865 VAR， 这是 VAR 是虚功率的单位。那我们怎么去算？要加多少电容值呢？那我们就是利用这个复数功率的公式，所以这个公式呢必须要背起来。而且这个公式呢是并联时使用的，因为你会发现呢它是 v 平方除以 r 的形式。那因为这里的是大小值，所以前面都有1/2，所以你有实数的 v 平方除以 r。对于虚数呢，它是 v 平方除以 x。所以首先就是要找这个 x 的值到底是什么。那我们去计算呢，电容的阻抗值，它的公式是1除以 j 欧米伽 c。那所以呢，它的欧米伽是角频率哦，所以它的欧米伽呢，它的电压的角频率是120拍，所以你写这个电容的阻抗值是1除以 j 120拍 c。那我们习惯是把这个虚数把它放到这个分子的地方，所以上下统称 j， 所以你得到一个 xj， 所以 x 会是负值。OK， 好，所以呢，我们又回到最后一个式子哈，所以呢，你的这个虚功率的减少都是这个 x 贡献的，所以虚功率呢，它的变化都是 x 贡献的，所以虚功率变化呢，所以虚功率它降低了 x prime 减 q prime 减 q， 虚功率降低了这个96.865减200，它会是这个 x 贡献的。因为 x 这边有个负值，所以你把 x 呢带到这个方程式里面，然后我们只有用虚数的部分，因为我们现在只看虚数，而且呢，所以我们也不记 j， 我们只看这个虚数的部分，1/2的 v 平方除以 x 的部分，所以呢，你会得到一个负的值96.865减200，这个负的值呢都是由你的这个 xj 所贡献的，你的这个 x。OK， 好，所以你得到这个负的值呢，是一个1/2的 v 平方除以 x。那你 x 用这个-1除以120拍乘以 c 代入，你就可以算出来它的电容值。所以你要并联呢13.679 μF 的电容到这个电路上面。 你就可以将我们的功率因子提升到 0.9， 这是一个减少我们的虚功率的概念。好，所以这个会考 ，this is important and this will be in the final exam. Okay. So let's look at the final problem that we are going to review, which is this. Okay, you are given a circuit, you are given this circuit, and it asks you to find VCT in the steady state, find the phasor current through each element. So you need to find the capacitor voltage in the steady state. And find all the, and remember, it asks you to return in a function of time. And it asks you to find the phasor current through each element. Right here, you have a phasor current. This is I. So for everything is phasor, we put bar on top. And phasor current through the inductor. You have phasor current through the resistor. You also have phasor current through the capacitor, and construct a phasor diagram showing the currents and source voltage. Okay, so to find out VCT, you need to calculate first you need to find out the phasor voltage of this, of Vs, but this is in sine, so we need to convert it to cosine. So we look at the sine cosine conversion, and as we talk about in the class, we have cosine, we have sine. So if it's in the direction of if it's in counterclockwise, if it's in counterclockwise direction, it is positive. But right now it is in clockwise direction, so it's negative. It's minus 90 degrees. So we have cosine theta minus 90 degrees equals sine theta. And so we always start from cosine, because we want to convert to cosine. So we start from cosine. So we have this, since we have this, and theta, we use 1000 T. We put 1000 T, we replace theta with 1000 T. So we have 10 sine 1000 T equals 10 times cosine 1000 T minus 90. So we know Vs, the phasor voltage of the source is 10, and degree is minus 90 degrees. So this is our first, you need to find out. Okay, so let me explain in Chinese. 所以第一件事情，他说你为了要去找出来这个电容的稳态电压值，那因为它是一个交流电，它是一个电压是一个 sin， 所以我们要利用的是这个稳态交流稳态分析。那首先我们就是要把电压源转成 cosine 的形式，才能把它写成向量。那我们就是利用这个 sin cosine 转换。那我们上课的时候介绍一个方法，就是你把这里是 cosine theta， 这里是 sin theta， 然后我们再增加相位角还有减小相位角的法则呢，我们是当我们的方向是反时钟方向，就是 counterclockwise 的方向，那是此时角度是增加的。那如果是顺时钟方向， 的话，角度是减少的。所以这里呢 cosine 是在右边 ，sin 是放在这个右下方，所以那它的角度呢，相差的角度由 cosine 开始，我们永远从 cosine 开始 ，cosine 西塔减90度等于 sin 西塔，那此时我们西塔用1000t 取代，那所以你会得到10sin 1000t，这个就是我们的 VST 会等于10 cosine 1000t 减90。所以我们就是等于成功的把这个 VST 呢写成 cosine 的形式，那我们就可以把它写成向量的形式，它的大小值是10，角度是负90度。Okay, so this is the first step. Convert the voltage source to its phasor representation. And second, we need to convert everything to its impedance. So we convert the inductor to impedance is J omega L. Okay, so you have this, the impedance of the inductor ZL, and we need to convert capacitor to its impedance ZC. So, and this is minus 100 ohm. Remember, the unit of impedance is ohm. Okay, and we have R. The impedance of ZR is just 100 ohm. Right, this is ohm. Okay, so it's just the same. The impedance of a resistor is just the same. Okay, and then so to calculate current, but in this case we just need to we calculate the equivalent resistance. We put C and R in parallel first. So this is C and R in parallel. We say it's ZRC. So to calculate what they are in parallel, we use the same concept as resistors in parallel. So we have this. So we have what? We have this is 100 and ZC is minus J 100 and ZR plus ZC is 100 minus 100J. And we need to do the complex division of complex value. We convert them to phasors and do the division. So this is what we have. We have this. No, what happened? Okay. We have this is the what we have, and so this is ZRC. So ZRC, let me switch to red. So these two is ZRC. And so we need to find out VC because they are in parallel. So to find out VC, we'll just apply voltage division rule. So voltage division rule tells us to find out VC, you just need to use VS times ZRC is on the numerator and denominator is ZRC plus ZL. So which is this, and so the summation of impedance, the summation of two complex number, we need to convert it to a rectangular form. So this is rectangular form, and then this, and to do the multiplication and division, we need to convert them back to the polar form. So this is the polar form. So in the end, we have this VC equals 10 and degrees minus 180 degree, and then we write it in as a time function. So VC equals 10 times cosine 1000t minus 180 degrees. So this is VCT. 好，然后接下来呢，我们说要这一题要求 VCT。那 VCT 的话呢，我们先去计算呢这个电阻跟电容它们并联时候的阻抗。那我们说它的并联的阻抗是 ZRC， 那我们就是由我们就是用跟那个电阻并联时候的公式一样。那因为电阻呢，阻抗我们可以把它视为电阻，所以它们有相同的单位，omega， 对，它们的相同的电阻值单位吼，不是 omega 是 ohm， 相同电阻单位是欧姆。好，这是欧姆，虽然说它是大写的 omega， 但它是欧姆。那算出来 ZRC 之后呢，那你要求 VC 的值，就可以由这个分压原理 （Voltage Division Rule）。那为什么用分压原理呢？是因为此时你可以把它看成这个是电感跟这个等效的阻抗串联。那你有一个电压源，所以就是这个电压源呢乘上分压原理，它的分子是 ZRC， 就是你要求这个电压的阻抗，那它的分母就会是 ZRC 加上 ZL 这两个的串联的阻抗值相加。那我们一样，我们是利用这个复数的计算公式。复数的计算公式呢，在加减的时候，那是用这个 rectangular form， 我们的卡式坐标系哈，所以你就是把它转成实数跟虚数相加。那在乘除的时候呢，我们都习惯是用 polar form， 就是我们的极坐标系来计算。那经过计算后呢，它的这个 VC 的向量是10，角度是-180。那题目要求你写出这个 VCT， 把 VC 写成 T 的函式，那你就可以把 T 的这个 steady 函式写出来。这是 VCT 的这个交流稳态解。OK。So this is the answer to the first question. And it also asks you to find out the currents through each element. So you are asked to find out I, IR, and IC. So to find out IR, before we move on to the next page, to find out IR can be calculated by using, since you know VC, right? VC is also the voltage across R. So IR can be calculated by VC divided by ZR, right? Because VC is the voltage across R, and VC is also the voltage across C. So you can use VC to find out IC. IC is what? IC is VC divided by ZC. Okay, and to find out the current through the inductor, we can, because it also need to satisfy KCL. So by KCL, we know I, the phasor of this current I equals IC plus IR. This is KCL. Okay, so by using these three equations, you should be able to solve the current through each element. So by using Ohm's law, since you know VC. By using Ohm's law, since you know VC, and this is KCL. Okay, so on the next page, it is just a Okay, and so it's not like that. It actually it is doing. You calculate the overall impedance and calculate I, but also you can prove. Yes, it can be proved. So I just write it here. You can prove I equals IR plus IC. And they should be the same. Okay, so you can prove that. So you need to convert this polar form back to rectangular form, and they should be the same. Okay, and to write down the phasor diagram, this is called phasor diagram of this I. So you can write you can, this is IC. IC is 0.1 minus 90 degree, and this is IR. IR is 0.1 minus 180 degree, and this is I. So I should be IR plus IC. So its relationship is this. Okay, so if you still do not understand, please think about it twice. Okay, so this will be in the final exam. 好，那这个算法跟我上一页讲的有点不太一样，它把它的总阻抗算出来了，它把它的总阻抗先算出来，就是 z total，然后嘞，算出 z total 之后呢，再去用欧姆定律 ，I 等于 Vs 的向量除以总阻抗，把它的这个电流算出来，因为这个 I 呢刚好也会是通过电感的电流。那一样，它这边是用这个欧姆定律。既然你求出 Vc 了，你用欧姆定律就是可以去求 IR 跟 IC，然后它会符合 KCL，因为 KCL 是一定，不管它是直流还是交流，的电流的形式都会符合 KCL，所以你应该会，你既然算出这三个值了之后，你如果把它转成这个 rectangular form， 就是卡式坐标系，你会得到这个式子，就是 KCL I 等于 IR 加 IC。那因为它是复数形式，所以我们可以在这个 phasor diagram， 我们在一个复数平面上，这是相位图，它是一个复数平面上画出来。你在复数平面上画出来之后，你就会发现，其实它就要符合 KCL， 它的向量会符合 KCL。OK， 好。Okay, so this is the second problem, and our last problem is this. So in the previous example, compute the power and current. Compute what? Compute power and reactive power taken from the source. Also compute the power and reactive power delivered to each element. So same thing here. You calculate V and I because same thing you calculate this is Z total. If you want to calculate the apparent power, real power and reactive power, we need to calculate the overall voltage and overall current. And once you find it out, you can find out VIMS, IIMS, and theta Z. So we find out this, and this is the theta Z in the previous case. So we can find out apparent power, and remember its unit is VA, and this theta Z. And then you calculate real power or true power, and this is this. And the reactive power is just 0.5 VAR. So it's the same procedure as we talked about in the previous example. And let's look at the last part. Compute the power and reactive power delivered to each element. Okay, and so because in the previously we solved the current, we solve IR, and we solve this is IL, this is I, and we solve IC. Okay, so once we have the current, then it will be really convenient. So to calculate the real power and reactive power. So for real power, because real power delivered to the resistor is just IR RMS squared times R, which is 0.5 watts. Okay, and so the reactive power delivered to L is just IL RMS squared times ZL. It's a positive J number is 1 VAR, and the reactive power delivered to the capacitor is just IC IMS squared times ZC. So this is minus 0.5 VAR. So you can notice the calculation of power, even for impedance, it's the same formula as what we talked before. Is V squared divided by R. Is the same as resistors. But right now they are just using RMS value. Okay? And then another thing to notice is because we calculate the power delivered to these three elements. Delivered to the resistor, delivered to the capacitor, and delivered to the inductor. And if you look at the power, so we for the left part, we calculate power, we calculate the overall power. It has true power, reactive power, and apparent power. So on the right side, we calculate the true power consumed by the resistor, which is 0.5 watt. So this is the real power, 0.5 watt. And we also calculate the reactive power giving and receiving from this reactive element. We calculate them individually, but the summation of them, 1 VAR minus 0.5 VAR is 0.5 VAR. So these two are the same. So on the left is overall, and on the right is we calculate is the power of its overall power, and on the right is the individual power, and they should be the same. 好，那这一题的这个市载功率、实功率跟虚功率，我们讨论这个市载功率、实功率跟虚功率的时候，是一个用整体电路的概念来讨论的，所以我们会把它的这个，我们只需要知道它整体电路的这个电压的这个向量，那我们整体电路电流的向量，那我们就可以把这几个功率算出来。那这一题他又加问了，他加问说，你每个元件消耗的功率。好，那我们刚刚在刚的例题前一页呢，我们把这个通过每个元件它的电流的向量都算出来了。那此时呢，我们就是可以利用这个，我们可以利用这个
功率的公式。那这个功率的公式其实跟只是电阻的功率公式一样，就是我们可以用 I 平方 R， 因为我们求出电流了，流过各个元件的电流，所以我们可以用 P 等于 I 平方 R 这个公式来算。只不过现在呢，我们是 P 等于 I 平方 Ms 平方 Z。我们现在用的是，而且算出来它可能会是个负数 ，I 的 RMS 平方 Z，因为现在是负数。好，我们就是用这个公式。那我们算这个，先算这个电阻消耗的功率好了，因为电阻一定是消耗10功率，所以我们用 IMS 平方乘以 R， 那其实这也就是 ZR 的意思了。但 ZR 跟 R 是一样的，你们必须要知道，这是 ZR。OK， 那 ZR 是100，是 0.5 瓦，意思它是10功率。那我们再去看呢，再去计算这个电感跟电容它们消耗的功率。那你要知道哦，电感跟我们之前一直讲过，就是电感跟电容呢，它是反应元件，那它消耗的平均功率会为0。那我们所说的这个虚功率呢，是它在前半周期就是会供电会耗能，后半周期是功能，所以这个虚功率呢，就代表它的这个它也是一个周期函数，虚功率代表它耗能跟功能的这个功率的正负。OK，所以是虚功率嘛。那这个电感的虚功率会是正的，因为电感它的阻抗值是正的，所以你得到一个。那我们在讨论它的虚功率，就是用 VAR， 虽然说它是虚数，但是我们其实是写 one VAR。OK， 好，然后那我们的这个电感它的阻抗值是负的，所以它的功率呢，它的虚功率会是负0.5 J， 那我们也是写负0.5 VAR。我们在讲的时候就不讲这个虚数的这个 J 了。那你会发现哦，把它的功率加起来，把这3个功率加走，你会有0.5瓦特的实功率，还有0.5 VAR 的虚功率。那你再看一下我们的左半边，它的实功率对于整体电路而言，实功率是0.5瓦特，它的整体的虚功率呢是0.5 VAR。其实这两个你不论怎么看都会符合哈，就是一个是以整体的角度来看实功率跟虚功率，另外右半边呢是以个别元件的角度呢来看实功率跟虚功率。那以个别元件角度看的实功率跟虚功率加起来，它的答案呢会跟以整体的角度来看实功率、虚功率呢是一样的。Okay, so this is our final review. Okay, so and this is the end.